Hello everyone, I am Ahmed Senior Ismail. I had a great opportunity to participate in the Praise Summer of High Performance Computing 2022. I worked with my mentors at Capgemini Engineering Company, Toulouse in France. The topic of my project is optimization of neural networks to predict results of mechanical models. I would like to start by getting you acquainted with the motivation for this project. Modern industrial projects involve various technical stages before production, for instance, the design, the sizing, and the certification stage. These stages require building models and running heavy calculations such as finite or discrete elements based on specialized softwares. However, oftentimes, the studied components share similar parameters that makes it possible to group them into various parametric classes. Hence, this makes it possible to be handled using machine learning. Coming to the introductory part, what is a neural network? Neural network is one of the most prominent and important applications of machine learning. It is a process inspired by the functioning of the neurons in the human brain. Typical neural networks are input and output system with a layer structure. It comprises of three major components, that is, the input layer, which propagates the input signal or features, the hidden layers, which made up of computational unit neurons, elaborating signals from previous layers, and lastly, the output layer, which provides the final output signal, all linked by weighted connections. Building performant neural networks require a lot of data and a lot of computational resources. Basically, these limitations are the major reasons why high-performance computing cluster is a necessity in order to search for robust network. Nevertheless, neural network is a universal approximator. The universal approximation theorem states the existence of neural networks for every continuous function, but does not explain how to find it. Now, moving to the methodologies of the project. This project focuses on building neural networks to predict the result factors of mechanical components and to improve the precision relative to its lowest possible error threshold. Here, the accuracy is defined as a ratio of errors under a threshold and the total number of samples, while the precision of the model corresponds to the smallest error threshold with a perfect accuracy. Conversely, the accuracy of the model were considered for both relative and absolute error. While trying to improve the precision of the model, we explored different methods like higher network capacity, higher numerical precision, and non-linearities of the features, all having variant effects on the model's performance. The bar chart shows the precision of 0.1% for the models, which is quite sufficient for a lot of industrial applications. And just before the vote of thanks, I would like to highlight the relevance of HPC to this project. Our training was based on synthetic datasets, which means that we have both the capacity and the quality under control. Taking these aeronautical components as a case study, the dataset contains parameters of the geometry, the material properties, and the applied forces as features, while the target is the result factor. High-performance computing is a good resource for neural network training. In order to fit good models, there are some parameters related to random choice which needs to be fine-tuned, and the only direct way to do this is to run a lot of calculations. For instance, running model parallelization for thousands of epochs in more than 20 cases might have been difficult to obtain in a short while. However, thanks to HPC, that's all I have to present. I hope you enjoy my presentation. Now to the vote of thanks proper.